In our first video about ellipses, we're going to go through that first page of notes, and we're just going to simply describe how do I break down the equation for an ellipse. So when I start looking at this, the first question is, how do I cut a cone to get an ellipse? Well, we're going to cut it. And not only diagonal, but diagonal and not through the bottom. So we have to go diagonal through the side, kind of like that. And if you hold that shape up, once you cut it diagonally, you're going to see that that does form an ellipse. In terms of constructing an ellipse, every ellipse is centered around this idea of having what we call two foci. Two foci. So a circle had one main center, and then you would go an equal distance away from that. An ellipse has two foci. And if you go online, you can find some videos where you look at the foci, they put little poles there, and you stretch a string. And as you move the string around, the string is going to form the ellipse, and the string goes from one pole to the other, and then kind of back to the other pole, and it creates that ellipse as it goes around. Technically, the definition is if you pick any point on the outside, distances to the foci, if that's D1 and D2, if I take their sum, and actually put the appropriate thing here, there we go, D2, and then pick any other point, for example here, make that D3, D4, the sum of the distances are equal. So sum of the distances are equal. That's not the most important thing. Honestly, what's more important is knowing to cut diagonally through a cone. Our main focus is going to be on this equation here. And the ellipse equation is slightly more complicated than the circle equation, but it has the same basics. If you look here, the center is still pretty much the same. I have my H and my K. So center's at HK. We take the opposite of the insides again in order to get that. The difference is I have this idea of A and B. A and B. So what I'm going to say is A is going to be the distance from the center to the outside in the x direction. So we're going to call A the distance from the center to the outside in the x direction. Notice how A is with the x term, so that makes sense. So that makes B the distance from the center to the outside in the y direction. I'm going to do a little bit of scrolling here, but going down to my picture, I'm going to label A and B. So if I go down to my ellipse, let's say that there's the center. This distance from there to the outside is what we call A. And this distance from there to the outside is what we call B. That's going to help me graph these ellipses pretty easily. Graphing an ellipse is rather easy. In terms of putting the graph on there, it's a little more difficult when we get to the other pieces. But straight up graphing, we could graph it with just that information, just like we do a circle. We have something called the minor and the major axis. Let me scroll back up. I don't know why I scrolled. The major axis is the line across the ellipse that is longest. In other words, either the vertical or the horizontal line across that ellipse is longer, whereas the minor axis is going to be the line across the ellipse that is shorter. Now this is going to change depending which orientation my ellipse has, if it's horizontal or if it's vertical. So looking down at this example, if I look here, the whole way across from there to there is going to be the major axis because it's longer, it's the longer of the two, and from there to there is the minor axis. And we're just going to report those in terms of how long they are, major and minor. If your ellipse happened to be that way, your major axis would be color. Your major axis would be this one there, going in the vertical direction. Just as a little FYI. So it depends what the orientation of the ellipse is as to what we call the major and what we call the minor axis. We have vertices and co-vertices. Vertices are the points at the end of the major axis. The co-vertices are the points at the end of the minor axis. So we just have different names for these points, and these are going to be the 4 points that we would use to graph. So for example, that point, that point, that point, and that point. This guy here would be a vertex because he's on the major axis, and this guy here would be a co-vertex because he's on the minor axis. So there's a pretty good picture of what an ellipse looks like in terms of just graphing it. But like I said, way up at the top, ellipses are actually constructed based on these two important points called foci. Two important points called foci. So in order to actually find the foci, because they're what we use to construct it, the foci are a distance. Let me get red. Looks better. Distance, that's still green. Distance, that's red. Of C away from the center on the major axis. Distance of C away from the center on the major axis. So that leads to an obvious question of what is this C value that you talk about? Well, in order to find C, we're going to do something with A and B, and it's one of two things. It's either, so C equals the square root of B squared minus A squared, or the square root of A squared minus B squared. It all depends on which one's larger. So we want to do whichever square root is going to give us an answer that is not imaginary. So if the A is larger, he'll go first, or if the B is larger, he'll go first. So if I just want to add those foci to my picture, I'm going to be along the major axis. So I'm going to go distance of C, which might be, I don't know, there and there. Once I find that C value, that's how far away my foci are from the center. So when I go to graph an ellipse, I have the center, I have vertex, I have a co-vertex, and I have these foci. And that's going to give me a good picture of what an ellipse looks like. In the next video, we'll go through and we'll do some examples of how do I actually graph ellipses and how do I calculate where the foci are in plot.